Imagine a disease so terrifying that entire naval fleets were destroyed by it, not by cannon fire, not by storms, but by the absence of a single molecule. Sailors' teeth fell out, their gums turned black and rotted, their old wounds that had healed years before, reopened on their bodies. They bled from the inside, they lost their minds before they lost their lives. This disease was called scurvy. Between the 15th and 18th centuries, it killed more sailors than all wars, storms, and shipwrecks combined. Historians estimate it may have killed over 2 million people. The cure was a lime, a single lime per day. One citrus fruit, costing almost nothing, contained the molecule that would have saved every one of them. That molecule is vitamin C, and what it does inside your body goes so far beyond preventing scurvy that most people, even today, have barely scratched the surface of understanding it. Vitamin C, also known as ascorbic acid, is a water-soluble vitamin. It dissolves in water, travels freely through your blood and tissues, and cannot be stored in fat like vitamins A, D, E, or K. Your body uses what it needs and excretes the rest in urine. This has a critical implication. You cannot stock up on vitamin C. You must consume it consistently every single day because your body has almost no reserve supply. Run out, and the consequences begin within weeks. Here is something that surprises almost everyone. Humans are one of the only mammals on Earth that cannot synthesize vitamin C internally. Most animals, dogs, cats, horses, mice, goats, produce their own vitamin C in the liver, on demand, in enormous quantities. A goat under stress will produce up to 100,000 milligrams of vitamin C per day. Your body produces 0. At some point in our evolutionary past, roughly 61 million years ago, a single genetic mutation disabled the enzyme our ancestors used to make vitamin C. We have been entirely dependent on food ever since. We share this genetic defect with all other primates, guinea pigs, and a handful of other species. It is one of the most consequential mutations in human evolutionary history, and most people have never heard of it. The history of vitamin C is one of the most dramatic stories in the history of medicine, filled with naval disasters, colonial expeditions, brilliant scientists, bitter controversies, and one of the most important Nobel Prizes ever awarded. Scurvy has been recorded throughout history. Ancient Egyptians described it. Hippocrates wrote about it. But it became catastrophic only in the age of exploration, when ships began making voyages lasting months or years, far beyond the reach of fresh food. In 1497, Vasco da Gama lost 100 of his 160 crew members on the voyage to India, most to scurvy. Magellan's circumnavigation of the globe in 1519 began with 270 men. Only 18 returned. Scurvy had claimed the rest. In 1747, a date that should be taught in every school, a Scottish naval surgeon named James Lind conducted one of the earliest controlled clinical trials in medical history. He divided 12 scurvy-ridden sailors into groups and gave each group a different dietary supplement. Only one group recovered rapidly, those given oranges and lemons. Lind published his findings. The British Navy largely ignored him for 50 years. When they finally issued lemon juice to all sailors in 1795, scurvy virtually disappeared from the Royal Navy overnight, ending centuries of needless death. The actual molecule, ascorbic acid, was not isolated until 1928, when the Hungarian biochemist Albert Szent Györgyi extracted it from adrenal glands and identified its structure. In 1937, he was awarded the Nobel Prize in Physiology or Medicine for this discovery. It remains one of the most important biochemical achievements of the 20th century. the story does not end there. In the 1970s, two-time Nobel laureate Linus Pauling, the only person in history to win 2 unshared Nobel Prizes, made an explosive claim that megadoses of vitamin C could prevent and treat cancer. The scientific establishment ridiculed him. 50 years later, the debate is still not entirely settled. Now, the science. Because what vitamin C does in the human body is so expansive, so fundamental, so deeply woven into every system you have, that describing it as simply an immune booster is almost insulting to the molecule. Collagen synthesis. This is vitamin C's most essential and irreplaceable function. Collagen is the most abundant protein in the human body. It is the structural scaffold of your skin, your bones, your tendons, your blood vessels, your organs, and your corneas. Without collagen, you literally fall apart. This is exactly what happens in scurvy. The body's collagen begins to disintegrate. Vitamin C is required at 2 specific enzymatic steps in collagen synthesis. Without it, the collagen triple helix cannot properly form. This is why scurvy patients have wounds that reopen. Wounds that had healed years earlier suddenly destabilize because the collagen holding them together is degrading faster than it can be replaced. Antioxidant defense. Vitamin C is one of the most powerful water-soluble antioxidants in the human body. Every second, your cells generate reactive oxygen species, free radicals, as byproducts of energy production. Left unchecked, these molecules damage DNA, oxidize LDL cholesterol, destroy cell membranes, and accelerate aging and disease. Vitamin C donates electrons to neutralize free radicals, converting them into harmless molecules. It also regenerates other antioxidants, including vitamin E, after they have been oxidized. It is not just an antioxidant, it is an antioxidant that recharges other antioxidants. The immune system. Vitamin C is concentrated inside immune cells at levels 50 to 100 times higher than blood plasma. This is not an accident. Neutrophils, the first responders of your immune system, actively accumulate vitamin C to extraordinary concentrations. When an infection strikes, they use it to generate oxidative bursts that kill pathogens. Vitamin C also stimulates the production and function of lymphocytes, the immune cells responsible for adaptive immunity and immunological memory. It enhances the activity of natural killer cells that target virus-infected and cancerous cells. It supports the integrity of the epithelial barrier, your skin and mucosal surfaces, the first line of defense against infection. Iron absorption. Vitamin C dramatically enhances the absorption of non-heme iron, the type of iron found in plant foods. It converts iron from its ferric state to its ferrous state, which is far more readily absorbed by the gut. Consuming vitamin C alongside iron-rich plant foods can increase iron absorption by up to 300%. This single fact is life-changing for anyone following a plant-based diet. Neurotransmitter synthesis. The brain requires vitamin C to produce 2 critical neurotransmitters, norepinephrine and serotonin. Norepinephrine controls attention, focus, and the stress response. Serotonin regulates mood, sleep, and emotional stability. The enzyme that converts the amino acid tryptophan to serotonin requires vitamin C as a cofactor. Stress and the adrenal glands. The adrenal glands, which sit atop the kidneys and produce your stress hormones, have the highest concentration of vitamin C of any organ in the body. When you are under physical or psychological stress, your adrenal glands consume vitamin C at an accelerated rate. Cortisol synthesis requires vitamin C. This is why acute illness, surgery, and severe psychological stress dramatically deplete vitamin C levels. Wound healing. Vitamin C is essential for every phase of wound healing, from the initial inflammatory response to the proliferation of new cells to the remodeling of tissue. Surgical patients with higher vitamin C levels consistently heal faster, with less scarring and lower infection rates. Burn victims are among the most severely vitamin C depleted patients in medicine. Cardiovascular health. Vitamin C protects the lining of blood vessels, the endothelium, from oxidative damage. It regenerates tetrahydrobiopterin, a molecule required for nitric oxide production. Nitric oxide relaxes blood vessels, lowers blood pressure, and prevents clotting. Low vitamin C levels are consistently associated with higher rates of cardiovascular disease, stroke, and hypertension. Eye health. The lens and aqueous humor of the eye contain vitamin C at concentrations 20 to 70 times higher than blood plasma, among the highest anywhere in the body. This concentration protects the lens from UV oxidative damage. Low vitamin C is directly associated with higher rates of cataracts, the leading cause of blindness worldwide. Epigenetic regulation. Perhaps the most remarkable recent discovery, vitamin C acts as a cofactor for a family of enzymes called TET enzymes, which regulate DNA methylation, one of the key mechanisms of epigenetic control. This means vitamin C directly influences which genes are switched on and which are silenced. It plays a role in cellular reprogramming, cancer suppression, and potentially even aging at the most fundamental biological level. Scurvy is not ancient history. It is returning. Reports of scurvy have increased across developed nations in recent years, in the United States, the United Kingdom, Australia, and Canada. Doctors are diagnosing scurvy in children, in the elderly, in people who eat almost exclusively processed food. In the United States, approximately 7% of the population, roughly 23 million people, have severely deficient vitamin C levels. Up to 35% consume less than the recommended daily amount. These are not people in developing nations. These are people eating the modern Western diet. Subclinical vitamin C deficiency, low levels that do not yet cause overt scurvy but still impair function, is extraordinarily common and almost never diagnosed. Its symptoms masquerade as everything else: fatigue, irritability, depression, slow wound healing, frequent infections, bruising easily, rough, bumpy skin from follicular hyperkeratosis, joint and muscle pain, bleeding gums, dry, splitting hair. None of these feel like a vitamin deficiency. They feel like modern life. High-risk groups. Smokers. Each cigarette destroys 25 milligrams of vitamin C, and smokers need at least 35 milligrams more per day than non-smokers. The elderly. People with malabsorption conditions, those living on ultra-processed diets, people under extreme physical or psychological stress, hospitalized patients, especially those in intensive care. Critically, vitamin C is among the most fragile of all vitamins. It is destroyed by heat, oxygen, light, and alkaline conditions. Boiling vegetables destroys up to 50 to 90% of their vitamin C content. Microwaving destroys less. Steaming preserves more. Raw is best. Most people are cooking away the very vitamin their body is most urgently missing. Let us talk about food, because the first thing most people think of when they hear vitamin C is oranges. And while oranges are a fine source, they are not even close to the richest vitamin C food on Earth. The richest source of vitamin C on Earth is the kakadu plum, a small, tart wild fruit native to Australia. It contains up to 3,000 milligrams of vitamin C per 100 grams. That is roughly 50 times the vitamin C of an orange. The camu camu berry from the Amazonian rainforest contains up to 2,800 milligrams per 100 grams. The acerula cherry from tropical America up to 1,600 milligrams. Rose hips, the fruit of the rose plant, up to 426 milligrams per 100 grams. These are the true vitamin C superfoods. More accessible sources? Guava, 228 milligrams per 100 grams, making it one of the richest common fruits. Bell peppers, especially raw red bell peppers, contain 190 milligrams per 100 grams, more vitamin C than an orange. Far more people know about oranges. Almost nobody eats bell peppers for vitamin C. Kiwi fruit, 93 milligrams per 100 grams. Papaya, 62 milligrams. Strawberries, 59 milligrams. Broccoli, 89 milligrams raw, but remember, this drops sharply with cooking. Citrus fruits, oranges at 53 milligrams, grapefruit at 31, Brussels sprouts, kale, parsley, all significant sources. One critical note, plant foods lose vitamin C rapidly after harvest. A bell pepper that has been stored in a refrigerator for a week may contain 30% less vitamin C than a freshly picked one. Frozen vegetables, paradoxically, often retain more vitamin C than fresh vegetables that have been sitting in transit and storage for days. Vitamin C is the world's most widely consumed nutritional supplement. Billions of dollars of it are purchased every year, and yet most people taking it are doing so in a way that severely limits its effectiveness. The most common form is plain ascorbic acid, the synthetic form. It is chemically identical to the vitamin C found in food, and it works. However, it is acidic and can cause gastrointestinal discomfort at higher doses, particularly stomach cramping and diarrhea. Sodium ascorbate and calcium ascorbate are buffered forms. They are less acidic and far gentler on the stomach. This makes them the better choice for people taking higher doses or those with sensitive digestion. Calcium ascorbate also provides a small amount of calcium. Liposomal vitamin C is the most discussed premium form. The vitamin C molecule is encapsulated inside tiny lipid spheres, liposomes, that protect it from degradation in the digestive tract and allow it to be absorbed directly into cells. Research suggests bioavailability may be significantly higher than standard oral vitamin C, though the science is still developing. Vitamin C with bioflavonoids, compounds found naturally alongside vitamin C in whole fruits, may enhance absorption and extend the active life of vitamin C in the body. Quercetin, hesperidin, and rutin are common bioflavonoids found in vitamin C supplements. This reflects how food delivers vitamin C, never in isolation, always with synergistic compounds. The single most important thing to understand about vitamin C supplementation, your body has a saturation threshold. Beyond approximately 200 milligrams per dose, absorption efficiency drops sharply. The gut transporters that absorb vitamin C become saturated. Excess is excreted in urine, which is why high-dose vitamin C turns urine bright yellow. The solution: split your doses throughout the day. Rather than taking 1,000 milligrams at once, take 250 to 500 milligrams 3 to 4 times daily. This maintains a steady blood level and maximizes absorption. Slow-release or sustained-release vitamin C supplements are designed around this same principle. What about IV vitamin C, intravenous administration? This bypasses the gut entirely, achieving blood levels up to 70 times higher than oral supplementation can produce. At these ultra-high concentrations, vitamin C generates hydrogen peroxide selectively in cancer cells, killing them through oxidative stress. This is the basis of ongoing clinical research into IV vitamin C as an adjunct cancer therapy. The research on vitamin C and disease is among the most extensive and most contested in all of nutritional medicine. Let us walk through what the evidence actually shows. Vitamin C and cancer. Linus Pauling's 1970s claim that megadose vitamin C could treat cancer was initially dismissed, but the story is more complex than the dismissal suggests. Several clinical trials have since found that IV vitamin C, not oral supplementation, can selectively generate toxic concentrations of hydrogen peroxide inside tumor cells while leaving normal cells unharmed. Observable studies consistently show that people with higher vitamin C blood levels have significantly lower rates of several cancers, particularly cancers of the stomach, esophagus, oral cavity, and pancreas. Whether this is causation or correlation remains under investigation, but the mechanism is plausible. Vitamin C inhibits the formation of carcinogenic nitrosylamines, protects DNA from oxidative damage, and modulates the epigenetic processes that regulate tumor suppressor genes. Vitamin C and cardiovascular disease. A landmark analysis of over 120,000 people found that those who consumed the most vitamin C had a 42% lower risk of death from cardiovascular disease compared to those with the lowest intake. Vitamin C protects LDL cholesterol from oxidation, a critical step in the formation of arterial plaque. It reduces blood pressure through nitric oxide mechanisms. It lowers C-reactive protein, a key inflammatory marker. Vitamin C and infections. The evidence here is nuanced. Vitamin C does not prevent colds in the general population when taken as prevention, but it does reduce the duration and severity of colds by 8 to 14% when taken regularly. For people under extreme physical stress, elite athletes, soldiers training in sub-zero conditions, regular vitamin C supplementation reduces the incidence of colds by up to 50%. For severe infections, the evidence becomes more compelling. Multiple randomized controlled trials in intensive care settings have found that IV vitamin C significantly reduces the length of ICU stays, reduces ventilator dependence, and in some protocols, reduces mortality in sepsis, a leading cause of death in hospitals worldwide. Vitamin C and COVID-19. During the pandemic, vitamin C was thrust into the spotlight. Multiple trials showed mixed results for prevention, but several found benefit in critically ill COVID patients. The proposed mechanism, vitamin C replenishes depleted levels in critically ill patients, reduces the cytokine storm driving severe disease, and supports endothelial integrity in the lungs. Vitamin C and cognitive decline. The brain is one of the organs most dependent on vitamin C. The cerebral spinal fluid contains vitamin C at concentrations 4 times higher than blood plasma. Studies consistently show that low vitamin C is associated with higher rates of cognitive decline, dementia, and Alzheimer's disease. Whether supplementation can slow or prevent neurodegeneration in at-risk individuals is an active area of research. Vitamin C and longevity. A 10-year study of 19,496 people published in the American Journal of Clinical Nutrition found that those with the highest plasma vitamin C levels had a 20% lower risk of all-cause mortality compared to those with the lowest levels. A separate analysis found a 6-year difference in biological aging between the highest and lowest vitamin C groups. 6 years of life from a vitamin. We cannot discuss vitamin C without talking about skin because the dermatology and aesthetic medicine world has embraced vitamin C more completely than almost any other nutrient, and the science behind it is extraordinary. The skin contains one of the highest concentrations of vitamin C in the body, both in the dermis and the epidermis. It serves 3 critical functions in skin: collagen synthesis for structural integrity, antioxidant protection from UV-induced free radical damage, and melanin regulation for skin tone and pigmentation. Topical vitamin C, applied directly to the skin, has a well-established evidence base. Stabilized forms such as L-ascorbic acid at concentrations of 10 to 20% have been shown in clinical trials to reduce wrinkles, improve skin texture, reduce hyperpigmentation and dark spots, and protect against UV-induced photo damage. Vitamin C serum is unstable. L-ascorbic acid oxidizes rapidly when exposed to air and light, turning brown or orange, losing its potency entirely. This is why vitamin C serums must be stored in dark, airtight packaging and used within a few months of opening. A serum that has turned yellow-brown is no longer effective and may be causing harm. For skin health, both internal and topical vitamin C matter. Dietary vitamin C determines how much reaches the deeper dermis. Topical application addresses the outer epidermis more directly. The ideal approach combines both, eating enough vitamin C-rich food while using a well-formulated topical product. No discussion of vitamin C is complete without confronting its greatest controversy head-on. In 1970, Linus Pauling, winner of the Nobel Prize in Chemistry and the Nobel Peace Prize, the only individual ever to win two unshared Nobel Prizes, published a book called Vitamin C and the Common Cold. Pauling claimed that taking 1,000 to 10,000 milligrams of vitamin C daily, far above the recommended daily allowance of 90 milligrams, could prevent and cure colds and potentially fight cancer. The scientific establishment responded with scorn. His reputation suffered enormously. He was accused of quackery. Who was right? The truth, as with most things in science, is complex. Pauling was wrong about vitamin C preventing colds in the general population. The evidence does not support this. But he was ahead of his time in understanding vitamin C's role in cancer treatment, stress response, and the possibility that optimal levels are far above what the recommended daily allowance suggests. The recommended daily allowance for vitamin C, 90 milligrams for men, 75 milligrams for women, was set primarily to prevent scurvy. It is the minimum necessary to avoid overt disease. It is not the optimum amount for thriving health, peak immune function, or longevity. The difference between preventing disease and optimizing biology may be very significant. What is the safe upper limit? The tolerable upper intake level set by health authorities is 2,000 milligrams per day for adults. The main risk at high doses is gastrointestinal disturbance. There is a theoretical concern that very high doses may increase kidney stone risk in susceptible individuals, specifically those prone to oxalate stones. For most people, however, doses up to 1,000 to 2,000 milligrams daily are safe and well tolerated. Let us make this completely actionable. Here is exactly what the evidence supports for food, supplementation, lifestyle, and skin. Step 1. Eat vitamin C-rich foods every day, raw or minimally cooked. Target at least 5 to 7 servings of vitamin C-rich foods daily. Prioritize raw red bell peppers, kiwi fruit, guava, strawberries, raw broccoli, citrus fruits, papaya, parsley. Eat them fresh, not stored for days, not boiled. Step 2. Supplement strategically. If your diet is inconsistent or you fall into a high-risk group, supplement with 250 to 500 milligrams of buffered vitamin C, calcium or sodium ascorbate, 2 to 3 times daily with meals. Avoid single large doses. Consistent divided doses maintain steady blood levels. Step 3. If you smoke, treat vitamin C as a non-negotiable priority. Each cigarette destroys approximately 25 milligrams of vitamin C. Smokers need a minimum of 35 milligrams more per day than non-smokers, but the evidence suggests the true need is far higher. If you smoke, supplement daily without exception. Step 4. Support your skin from inside and outside. Eat vitamin C-rich foods consistently for dermal collagen support. Consider a stabilized L-ascorbic acid serum, 10 to 20% concentration, for topical application. Store it properly. Replace it when it turns yellow. Apply in the morning under sunscreen for maximum UV protection synergy. Step 5. Increase intake during illness, surgery, or extreme stress. Your vitamin C requirements can increase tenfold during severe illness or surgery. This is when supplementation matters most, not just for immune support, but for wound healing, collagen repair, and adrenal function. Hospitalized patients are among the most vitamin C depleted people on Earth. We began on a sailing ship. We end in your body right now, where vitamin C is working in ways that took science centuries to understand and is still not finished discovering. It builds the collagen that holds your body together. It defends your cells against oxidative destruction. It arms your immune system against infection. It makes the neurotransmitters that regulate your mood. It protects your heart and your eyes and your brain. It may even determine which of your genes are expressed. 2 million sailors died because they were kept from it by ignorance and institutional inertia. We are not kept from it by ignorance anymore. The science has been done. The evidence is overwhelming. A lime could have saved 2 million lives. A bell pepper, a kiwi, a supplement taken with breakfast. These are not trivial choices. They are decisions made at the molecular level with consequences that ripple through every system in your body. Vitamin C is not just a supplement. It is a molecule of survival, of structure, of resilience. It is the reason your wounds close, your immune system fights, and your body does not fall apart. If this video changed how you think about something you thought you already knew, share it. The people around you may be suffering symptoms they have never connected to something this simple and this fixable. Like, subscribe, and comment. What surprised you most? We read every single one.